There's a common misunderstanding that design of experiments and statistical approaches takes longer and slows down work. And in my experience, it is the opposite. The products I work with are typically for unmet medical needs, and so we need to make sure we have full understanding and control of the process, but at the same time, we want to move as fast as we can. So no compromise to safety, effectiveness, but moving really rapidly. Statistical methods and design of experiments are essential to accelerating progress. I mean, the perception that design of experiments can slow work down is just people thinking that there's an artificial requirement to follow a certain recipe that may not even apply. I mean, I do see a lot of cases where if at the beginning we pause and think about what are the constraints, what's the list of factors, what is the cycle time to run one of these, we can get a lot more efficiency and acceleration in results just by that little bit of planning up front and thinking carefully about what experimental strategy applies. Many people have been trained in that chemical view of design of experiments, thinking that it's a requirement to run a sequence of studies, to screen factors first and then optimize. But actually, a lot of the work I do now is with more biological processes, such as cell culture for vaccines and other products, gene therapies. The growing season of a virus can be quite long, but the list of factors is not extensive. It's not a list of 20 factors. So it's very feasible and desirable to do a study that's an all-in-one study in essentially one growing season or one cycle time for the experiments to study that shorter list of factors that's already been narrowed down by prior knowledge. Software's pretty trustworthy these days. If you're using a well-qualified package like JMP, then it'll get the math right. The important part is answering the right question. And then the very next thing, almost simultaneous, is looking at the data every which way you can think of. And of course, nowadays, I totally rely on JMP for that. There's an old saying that I love, wallow in the data. So don't just plop it in and make one graph. Look at the data, slice and dice it, look at it from every angle you can imagine, until you get a picture that delivers the message. The statistics part is kind of like secondary. I saw a presentation by a woman sharing the results of her very first design of experiments, and I was just amazed at how much she learned by just getting in there and doing it. So part of it, I think, is don't worry too much about getting it right, jump in and try it. I think the value of JMP is, first of all, it's so trustworthy. I mean, we know that a method that has been implemented in JMP has been tested and checked, and it works right. So that's a very high value. In other packages, you know, it varies. I think the huge value in JMP, though, beyond the trustworthiness, is its dynamic nature and the speed. So I just love working in Graph Builder because I make a graph, I start out, I never end up with my first graph is never the final one. One example I've been working on lately is a very traditional vaccine, and it is for a very important disease globally that needs to be eradicated. I'm working with a team right now that is looking at doing 2 years worth of experiments when they really only need 1 year. Think about the impact of that, of a product introduction a full year earlier than they're projecting, just by applying design of experiments.